Alright, welcome back everyone. Today we're going to start a new project series. This one I'm calling Cityscapes, and in this project series we're going to take a look at how to use geospatial data inside of TouchDesigner for real-time data visualizations or artworks that use real-world data. For this session, we're going to take a look at how to use OpenStreetMaps to collect some of the data that we're going to be using. But first, I'm going to show a few use cases of this data to see where you guys might be able to take these skills and give a couple examples of projects that are real projects that I'm working on that include these. So for example, here is a skyline of New York, and as you can see, we can nicely animate this point cloud to kind of dissolve as our curtain is falling, if you will. This is just a simple effect. That curtain falling could be driven by any number of pieces of data, in addition to audio reactivity, connect, whatever you want. So that is, again, just one example of how this could possibly be used. We're going to be looking at getting this building data into TouchDesigner in this session. And I'm a big fan of this effect. I think it's pretty clean and really conveys an emotional feeling to the viewer. So that's one. Another one is this one, which is a data visualization in working with city bike data. So if I restart it, in this visualization, what's happening is real-time city bike rides that are being taken all over the city of New York are being plotted by using an API and several different mapping services. And then we're using those routes to create obstacles for fluid to flow around using weather and other geographic specific data to drive the fluid itself. So again, just a couple examples to give a little bit of an idea where we might be able to go with some of this. But first things first, we need to actually get our data. So if you go to OpenStreetMap, you will be able to go find a place of interest, and you can actually use this manually select the area button. We can just grab kind of whatever little portion of the city you want. The downside to this is that you're really limited in the amount of data that you can grab. Even something like just a little bit of a bigger section of the city normally is going to cause issues on export, because they don't only let you export 50,000 nodes, and nodes include the road and the streets, and that adds up quickly when you're looking at densely populated areas. So we are going to use an alternative, and that alternative is going to be a software, and that software is called QGIS. So QGIS is a free software. The UI is not necessarily the best out there, but it is free, and there is a decent community to learn how to use it. So I recommend everybody go download that now. And once you have that downloaded, we're going to need to add a couple of plugins. So the plugins that you're going to need, you can add by going to plugins and then manage and install plugins. And then if we go to all, or for me, I'm going to go to installed because I already have these installed, but you'll need to make sure that these are the ones that you have installed. That is the Quick Map services. Monotim locator filter, and OSM downloader. Now, these should just download and install automatically. It should not be too crazy. The other one I forgot to mention was Quick Map Services, so make sure you add that as well. So we have Quick Map Services, we have the OSM downloader, and we have the Nominatim locator filter. So those you can just install, and then you'll just want to restart your QGIS to be able to get an instance running with everything in it. So again, there's a ton going on, and I'm just gonna barely scratch the surface because truly, I am still very much learning a lot of the deeper functionality of this myself. But to get to Open Map Service and our data download, we can go to Web, and we can go to Quick Map Services, OSM, and OSM Standard. Then OSM Standard is going to open up this interactive map. We can zoom and drag. And this interactive map is what will allow us to download a region of interest. So one thing to note is that this will let you download a lot, but we want to be careful that, especially for our sample and kind of learning how the pipeline works, we don't want to grab too much. And the reason for that is there's still going to be a lot of computations that we have to do with our data. And obviously more buildings are just going to result in heavier computation and a longer iteration time. So I'm going to stay zoomed in around like this. Now you can click on this right here, download OSM data by rectangle selection. And then what I can do is just click and drag, just like that. Point our save location. I'll just go to my downloads and say Philadelphia OSM. And then I will just click OK. It'll take a second to download because, as I mentioned, that is quite a substantial data set. But as it's doing that, we can open Houdini. So, as I've mentioned before, Houdini has many licenses that you can choose, but one of them is free. There's a Houdini Apprentice license. So, there we go. Our file's been downloaded. Our Houdini Apprentice license is free, so anybody can go grab that if you want to follow along with this part. I recommend it. It is pretty necessary to be able to build and clean some of this geometry. You could, in theory, get around it, and I will probably do a touch version of this flow later on, but at some point, this tool is just better. So I, again, recommend everyone download and install Houdini. Now, after you download and install Houdini, you are going to need to make sure to add the Houdini Labs, Side Effects Labs installation. This gives us some extra nodes that we can use, and we're going to be using several of those nodes specifically in today's work. So, follow these installation instructions, download Houdini, Side Effects Labs, and restart Houdini so that we can have an instance running with the lab tools added. Very good. So, for getting our data into Houdini to be able to clean it, and you'll see why we need to clean it as soon as we get this into Houdini. With the labs tools installed, we can just do tab and drop down a geometry node, jump inside the geometry node, then hit tab. Now type labs OSM, and what we're going to do is the labs OSM import. Then we can navigate to our downloads, which is here. Choose our OSM file. and then allow the import to happen. This might take some time, at least a couple minutes, depending how big it is. Now you'll see we don't see anything. That's probably because our location is somewhere random on the map. So you can click on the viewport, hold down space, press the H key, and that will home us to see the entire view. So now it is pretty clear why we're going to need to do some cleanup in Houdini. This is a much larger area than what we selected, and you can see that these look like roads. We're kind of grabbing huge extents of them, even though our actual area of interest is, whoa, very tiny relative to those roads. All right. Sorry. So if things are ever moving around too crazy, you can use Shift to give yourself a little bit more fine control. Okay, so one thing that we can do is use a quick bounding box to get rid of all this extraneous stuff. So to do that, we can just draw a Bezier curve, and I'm going to hold spacebar 2 in the viewport to get a top view. Then I'm going to hold spacebar and scroll to zoom back in. Now I still have the draw curve tool selected, and I'm basically just going to draw a line across just like that. And then you can just hit enter, and we'll have a curve. Now we can just hit a bound node, drag that in, click on this blue thing to see your new node. Now if I go back to the viewport, spacebar 1 will shift me back to perspective view, and there we go, back to perspective view. Cool. So then what we can do is basically, oops, I really need to, there we go. Then what we can do is use a poly extrude, or actually I believe with the bound we can maybe do, actually just do padding in the Y direction, not the X direction. And there we have a bounding box. So we don't actually need the poly extrude. And then what we can do is use a group node, drag the OSM import into one of the groups, or into the first input, drag the bounding box into the second input, then use bounding region, make sure to change our group type to points, and then we can set a bounding object. And then I will name this group area of interest. Now we can use a delete node. We can say delete non-selected, and then use area of interest as our group name. Why isn't this working? Area of interest is not a valid group. Ah, that would make sense. I accidentally named the node instead of the group. Now you can see that these are all the groups that we have in our OpenStreetMap data, so there's tons to pick from. I believe points. There we go. So just what was going on there was that I needed to have this set to points because my group was a group of points, So in the delete node, needed to look for a group called area of interest that was made out of points. So now we'll delete non-selected from that, and we'll turn off the template for our import. And now we can see that we kind of have just, we have just our area of interest here. Now, there is still a lot going on. I will create a null. I'll call this area of interest. Then next, we're going to drop OSM filter. OSM filter is another labs node. It will allow us to go in and actually select what we want out of this node. So I recommend some experimentation because each location's data is going to have a little bit different representation in here. But we can see that the buildings we can add or remove. We can add or remove different types of motorways. So residential, everything, all of that. We can add or remove other data. And I'll turn the template off so you don't get confused. Yeah, so now we have just our building selected. We can see that we have just buildings. Building parts will add a little bit, but normally not a ton. And then now, especially if I turn off buildings, we can see major highways, then primary roads, secondary roads, tertiary roads, residential roads, pedestrian traffic, sidewalks. If I get rid of the roads, the sidewalks become a bit more clear. And then this other, which I think is generally short stretches that are unclassified and or like greenways, little boulevards and stuff, at least as far as I can tell from seeing the areas around me. So for now, we're just interested in the buildings, but we'll probably come back and grab the roads later. So if you click on this eye, we can see kind of what's going on here. Now, right now we have 170,000 points and 21,000 primitives. That's actually not too bad. But if we selected a larger area, that number could be drastically larger. And we can see that by checking all of these roads, a number of points goes up, not crazy, but like by 30,000. So there is a little bit of cost. So we'll just keep the buildings, and I will drop another null, and I will just call this OSM buildings. Select. Because what we're going to do now is use the OSM buildings node. And this is a really handy script, which if you jump in, you can take a look at if you're interested. A really handy script that is going to pull the elevation data out of our buildings and then actually create three-dimensional structures. Now, this is a bit wild, as you can see. So our options are to either scale the Y values way down or to scale everything else way up. So I am going to just use a transform and scale the Y values by something like maybe 0.005. All right, now where is my geometry? Okay. There it is. So my geometry is over here. My transform is doing something weird. I don't like that. So I will go back here. Now we'll scale the Y, and that is working a lot better. You also notice that as our geometry is now much more contained, you can scroll and move around a little bit easier. So maybe 0.005 is a little much. Maybe that looks about right as far as realistic scale. You can also visualize the buildings and give them each a random color if you want. And you probably also want to go up here and have generate buildings with missing data flipped on in case there are some incomplete buildings that OpenStreetMap will want to use. So if you want, you could also put the transform in, I think, before the buildings. So no, that didn't work. I take it back. To the buildings we go. So now we're getting there. This is our buildings as desired. There are a couple other things we need to do. One is actually use a camera and position a camera to get rid of some of our back faces. This will just give us much cleaner geometry and cheaper geometry to work with in TouchDesigner. And the other thing is create a point cloud out of all this so that we can get our points and use the point clouds as well. So I will do yet another null. Call this buildings. I'm going to turn off the colors because I don't want the colors. And amazing. So I'm going to go back up to the object level. And I'm going to add a camera. Oh, another thing that we can do now that we have all of our buildings is use a center. And then that center will move us back to the origin. And then we can just use Shift H, or sorry, Spacebar H to get us back to our home. That's nice because now when we dropped our camera down, it's exactly where we need it to be. And now what we can do is move our camera a little bit, and we can actually look through it by piloting our camera, and we can kind of just move this around until we get a view or a scene that we are happy with. And then what we'll do is once we have our scene, we can take some of the faces from the geometry that are not apparent in our scene out of here, and that will allow us to have a much more lightweight geometry for us to bring into TouchDesigner. So let me see here. I think maybe I like this kind of cross angle a little bit. Something like this for Philadelphia, looking kind of at Center City and the surrounding area. So maybe something like this is kind of nice. So having our cam one. Now what we can do is use another group. I'm going to name this group Cull Backface. And then we can turn this group on. We want to enable keep by normals. And then we want it to be backface from our camera operator. Unable to find specified backface object. Well, we can always select it manually like this. See, I just didn't need the quotes in there. My bad. And then we can do another delete. And we can then delete our cull backface group. And so we go from what we have here, 340,000, 210,000 points. Or sorry, 210,000 primitives. Now we have about 300,000 points and almost 100,000 less primitives, which is great. And then we can delete non-selected. I don't actually know why we should delete the non-selected. I believe it's because backface from the camera is potentially, well, my best guess is that when the OSM data gets imported, the normals are flipped or something like that. I'm not exactly sure, but in any case, just know that we should delete our non-selected, and then we have the nice camera view here. And actually, look at that, that deleted so many more pieces of geometry. So we went from 210,000 up here. We went from 210,000 primitives and 336,000 points to 275,000 points and under 100,000 primitives. So great improvements, just what we wanted. Yet another null. We can call this backface culled. So now we can do some points. So I will use a scatter for the points. We can add something like 1,000,000 points. It'll take a moment. And we can scatter by density, count per primitive, or in texture space. I want to do by density and not scatter on voxels. And then your total force count is going to be the total number of points. So I have 1,000,000, and whoops, I have 1,000,000. And that is going to generate this point cloud, which, as we can see, has points that fill the volumes that are taken up by our geometries. Or, well, I guess in this case I just applied on the faces, but that's okay too. And it gives us this really nice point cloud representation of our geometry. So now we kind of have this geometry set up. We need to export it to TouchDesigner. And to get it out of Houdini and into TouchDesigner, we're going to need to do a little work with our data types. So let's jump into that in just a second. So the last thing that I want to do before we go through and actually export is see if we can narrow our field of view. So I think I'm going to grab some code, and I got the code from here. Hull faces outside of camera view. This little snippet, we can just copy this, and we can use a point wrangle. And this point wrangle should actually be up here. We can just paste our code in here. And if this CH means create a parameter channel. So what that really means is it's essentially like a custom parameter that's custom to this node. So if you press this button, it'll create channels or whatever, sliders for the custom parameters. So what's going on here is vector NDC. This is create normalized device coordinates. So in the render pipeline, normalized device coordinates are the coordinates that are used for the final camera space conversion before everything goes to the screen space. So here we're using a camera. We're actually just going to replace this with a path to our cam1. Here you do need the quotes. So two normalized device coordinates using this camera, and at P means our point position. Then our view is going to be determined based on this padding. You can already see what's happening as the padding is going up. And then basically, if our point is inside of a view frustum from this camera based on the padding and the angle, then we're just going to remove that point, and that will leave us with only points that are inside our view frustum from a camera at a specific location. This is also handy as it'll just let us go through and further reduce the geometry that we need to export and then use in real time. If we go back to our cam1, we can kind of see this working as we are restricting the view, increasing our padding. Our view is being called more. And if I maybe move out here so we can see the camera too. If I just wire that into the buildings and we take a look at the buildings, you can see that disabling this point wrangle will include all of our geometry, but then when we do enable it, we are just seeing this slice, and that slice is based on the camera. So if we were to go and move our camera, then this would change as well, which is super, super handy as we are iterating and trying to work through scenes procedurally. So that's a real good setup, and it will enable us to run the least amount of operations on all the rest of this geometry. So now that we have our points scattered, we are going to use a ROP network, and this is going to be our export point cloud. You can jump in, and we are going to use a vertex animation texture node. This vertex animation texture is what is going to allow us to grab all of the point data, or vertex data, really, and bake that into an EXR file that we can use as a point file in TouchDesigner. So we can select our back face called buildings. Oh, actually, no, I shouldn't do this. We should another null. We can call this point cloud. So now we'll select point cloud as our geometry. We want to make sure that our frames are just set from 1 to 2. We just want to do 1 frame. We want to make sure that we have particle sprites mode, Unreal Engine, and we do want to support interpolation. Otherwise, that's not going to work. Make sure we're saving as an HDREXR. And then finally, we want to make sure our texture width is appropriately sized. 1024 is going to be fine for us because we have less than that as far as points to store. See here we can use up to 2 million points per frame with this texture width, and that's because we're doing 32-bit float. We don't even need that, so we'll be fine. We do have an error though, and that is that we need the ID attribute for our particles. So we can use an attribute create and just create an ID attribute on our noise, or sorry, on our points. Then we can go in here and click render all, and it's going to take a second, but then it will save out an EXR file. That has our point cloud in it. Okay, so now my download has finished, or my export rather, is finished. So we can navigate to where that would be, which is going to be different, I guess, in everybody's system. I'm actually going to save this project and accept. Okay, and then I'm actually going to just re-render this because I need to go to that file. If you just hit render and you didn't have the Houdini file saved in a folder, then it just saved whatever your Houdini saved in whatever the Houdini directory is. So you can just go find it, or just do what I did and save it in a location and then export it again. So we can also open up a new instance of TouchDesigner. And then once we have our export, we will be able to drag and drop it in here. All right, I just got mine. So this is the folder that my Houdini file was saved in. So there will be an export folder created, an OSM export, and then we have two. There's a geo, which is a mesh. The mesh does not work with this type of export. We're going to export the mesh separately. But there is a texture, and if we put a, well, we can just drag and drop that position texture into TouchDesigner and view it as points. We can see that we do have our points really nicely imported into TouchDesigner. And we can also see that the view frustum is how we had it set up, right? That angle from our camera view, which is exactly as we wanted it. So that's working well. The other thing that we need to do now is update our geometry. So, where's my Houdini at? My other Houdini. There we go. Cool. So now we have to export the geometry. To export the geometry, you can do something pretty similar, but this time we're going to use a ROP geometry output. This ROP geometry output we can wire into our called backface null. We can call this export buildings geo. Now here we want this render current frame only, and we want to change this bgeo to bh classic. That's the file type that TouchDesigner will know how to read. And then we can just save that to disk. It'll again take a little bit to render that to disk, but once it does, we can go grab it in TouchDesigner. And then the last thing that I will do in Houdini, just while we're here, is go back up to this OSM filter. You can hold down Alt, click and drag to make a copy. I'm going to call one roads. I'm actually going to copy this filter as well and drag that filter into my roads. And here we will check roads and we will uncheck buildings. And okay. Where'd it go? Got very zoomed out again. Cool, so we can take our buildings off, and I'm gonna just do, whoops. Sorry, so make sure this one, which maybe we can make filter buildings. Make sure that still works. Good. Now we can go back to roads. Filter roads. And yeah, so for this one, I think I'm going to take off. Yeah, so I'll keep the rest of the roads. So I'm just going to uncheck footway and pedestrian. And then we can alt drag this export. You can do alt click to add a little guide node in the wires, which is a nice feature for keeping things handy, or sorry, clean. And then we'll just call this export roads, also already named BH Classic. So we don't have to do anything there. We can just save it to disk. Now, to your file explorer. There's a new geo file. So we'll go back to TouchDesigner. And we'll see what we got here. Alright, so we can see our buildings. Nice. Again, view frustum specific. And our roads, which actually are not view frustum specific because I was not view frustum specific because I grabbed the roads, and that was before we forked off before the point wrangle, which actually applies that view frustum and after the callback phase. So we can do two things. We could either split this off after and filter out the roads, but that's not really going to work because we don't have any roads to filter out at that point. So what's going to be easiest probably is just duplicating that point wrangle and see if that works. Doesn't quite appear to be working. Interesting. Well, I'm not exactly sure why that's not working at the moment, but I don't think it's the most important thing. So I am just going to actually ignore that, and we'll just use our roads without the view frustum. We can always go back and fine tune that later if it is necessary. So yeah, now we have our geometries inside of TouchDesigner, and from here there's so many things that we can do. So I think for this tutorial I'm going to stop it here. I think that it was probably a decent bit of work to get all of this up and running and integrated. So once we have these exports, I think we can take a pause, and then we will start next tutorial with set up our rendering network, integrating all of these guys, making sure we have everything aligned and that our different layers are working harmoniously. And then we can start building the cool effects and bringing in some other data sources. So with that, I'll stop here. Thank you guys again. Thank you to all my Patreon supporters. It's continually amazing. Really appreciate you guys. And I hope that everyone has some fun with this new OSM data project.